students, in the last class we have studied about the tangent and the normal. Now, tangent is a line that will touch the given curve in a single point. The point where the tangent will touch the curve is called as the point of contact. And at the point of contact, if you draw a line perpendicular to the tangent, that is the normal. Also, we have seen the relationship between the gradient of tangent and the gradient of the normal. Since tangent and normal are perpendicular to each other, the product of their gradients is -1. Or I can say that the gradient of normal is negative reciprocal of the gradient of the tangent. So today we'll see a problem on this. The point P with x coordinate one upon 6 lies on the curve y is equal to 3x square. Normal at P meets the curve again at Q. Meets the curve again at Q. And we have to find the coordinates of Q. Find the coordinates of Q. Now here, as you can see, for P, only x coordinate is given 1 upon 6. So let us determine the coordinate, y coordinate of point P first. Now, since the point P lies on the curve with equation y is equal to 3x square. If I substitute for x 1 upon 6, that is the x coordinate of point P, I will get the y coordinate of point P. So that means y is equal to 3 into 1 upon 6 the whole square, and that is 3 into 1 upon 36, which is 1 upon 12. Or that means the coordinates of point P are 1 upon 6 and 1 upon 12. So to make the problem clear, I will just put one graph here so that you can understand the problem very easily. So this is a graph here. So as you can see here, this is point P, whose coordinates are 1 upon 6 and 1 upon 12. Now, See that the point P is common to all three. This is point of contact, so it is on the curve, it is on the tangent as well as it is on the normal. So this is the normal that is drawn at P. It is perpendicular to the tangent and it is meeting the curve again in point Q. We have to find out the coordinates of point Q. So this is the curve width equation. Y is equal to 3x square. So now let us try to determine the equation of normal, and then if we solve the equation of the normal simultaneously with the equation of the curve, we'll get the coordinates of the 2 points of intersection. So our first step is to determine the equation of the normal. For that, first let us determine the gradient of the normal. So y is equal to 3x square. So what should I do to determine the gradient of normal? Obviously, first I will find out the gradient of the tangent. For that I will differentiate this curve's equation dy by dx, and that is equal to 3 into 2x, that is 6x. Now for point P, x is equal to 1 upon 6. So I will substitute x is equal to 1 upon 6 in this. So I will get dy by dx. I will put x is equal to 1 upon 6 in the derivative. So 6 into 1 upon 6, which is equal to 1, which means the gradient of the tangent at P is equal to 1. Now the gradient of normal is the negative reciprocal of the gradient of the tangent. So gradient of the normal at P is negative reciprocal of 1, that will be negative 1. See that 1 into negative 1 is minus 1. So now I will write the equation of the normal. Equation of the normal in the form y is equal to mx plus c. M is the gradient and gradient of the normal is negative 1. So y is equal to negative x plus c. I have put m is equal to negative 1. Now to determine the value of c, I'll substitute the point P in this. So P is 1 upon 6 and 1 upon 12. P's coordinates are 1 upon 6, 1 upon 12. Why am I substituting the coordinates of P in this equation? Because P also lies on the normal. As I already made it clear, P is a point which lies on the curve, on the normal as well as on the tangent. So I'll put x is 1 upon 6 and y is 1 upon 12. So I'm getting 1 upon 12 is equal to negative 1 upon 6 plus c. Or that means c is equal to 1 upon 12 plus 1 upon 6. and that is 1 upon 4. So I'm substituting back in this equation, and hence the equation of normal, the equation of the normal is y is equal to negative x plus 1 upon 4. Now my next step is I want to find out the coordinates of the point of intersection of the normal with the curve, and for that I will solve the equation of the normal and the equation of the curve simultaneously. Now equation of the curve is y is equal to 3x square. So what should I do to solve simultaneously? I'll just put y in the equation of the curve. Y from the equation of the normal, I'll put it in the equation of the curve. That gives me minus x plus 1 upon 4 is equal to 3x square. Wish this step is clear to you. What I have done, I just put y is equal to minus x plus 1 upon 4 in the equation of the curve. So for this y, I put minus x plus 1 upon 4, and hence I am getting minus x plus 1 upon 4 is equal to 3x square. Now since the denominator here is 4, I will multiply throughout by 4. So I am getting minus 4x plus 1 is equal to 12x square, or 12x square plus 4x minus 1 equal to 0. I'm shuffling the terms and getting the quadratic in the standard form. Ax square plus bx plus c is equal to 0. Now x square coefficient is 12 and constant is 1. So the product is 12. And the sign of the constant is minus. So I will factorize 12 in such a way that difference is equal to 4, which is 6 and 2. And since I want plus 4 plus 6 negative 2. So I am getting 12x square plus 6x minus 2x. I am splitting up plus 4x as plus 6x minus 2x minus 1 equal to 0. So from these two terms, I am grouping the terms. So from first two terms, I will take 6x common, which gives me 2x plus 1 here. And I am taking this negative sign out. And from 2x and 1, I can take only 1 common. So I am getting 2x plus 1 here, which gives me the two factors of quadratic, 2x plus 1 and 6x minus 1. So when I am equating 6x minus 1 to 0, I will get x is equal to 1 upon 6. And x is equal to 1 upon 6 is nothing but the x coordinate of point P, which already we have. So the other point Q, I will get by equating the second factor to 0. So 2x is equal to negative 1. So x is equal to negative 1 upon 2. I wish this part is clear to you. See that here x is 1 upon 6. This is the x coordinate of P. X coordinate of point P, which already you have, but you want to find out the second point Q, coordinates of the second point, and that will be given by equating the second factor to 0. So you are getting x is equal to negative half. So that will be the x coordinate of point Q. Now, this x coordinate of point Q, substitute in the equation of the curve or equation of the normal. Any one you can do because it is a common point. So I'll take y is equal to 3x square, and that is 3 into negative 1 upon 2 the whole square, which gives 3 into 1 upon 4, that is 3 upon 4. And hence coordinates of Q, coordinates of point Q are negative 1 upon 2 and 3 upon 4. So wish these steps are okay with you. So what you have done is, first, by differentiating the equation of the curve, we have found out the gradient of the tangent. Its negative reciprocal is the gradient of normal. And keep it in mind that point P, that is the point of contact of the tangent, it's common to all three: tangent, normal, as well as curve. So using that point, I have written the equation of the normal, and since I want to find out the point of intersection of the normal with the curve, I have solved the equation of the normal and the curve simultaneously. I have got two roots. Out of that, one value of x gives the x coordinate of point P that already we have. So I have taken the other value, substituted it either in the equation of the curve or equation of the normal, and got the coordinate of the other point of intersection. Okay, so I will give you a similar problem to do for the homework.
Try this problem as a homework, students. The point P with x coordinate 2 lies on the curve with the equation y is equal to 2x square plus 1. Normal at P meets the curve again at the point Q. You have to find the coordinates of Q. A very similar problem, only with change of numbers. So just try it out. See you in the next class, students. Enjoy the day ahead. Any doubts, please ask me in the next class. Your doubts are always welcomed. Bye, students.